Hi everyone, thanks for watching my useful contents. Today I would like to show you how to do Box Cox transformation by PPCC, which means probability plot correlation coefficient. There is one reference site I used for this video. The maximum probability plot correlation coefficient method is actually based on finding the value of lambda that maximizes the correlation coefficient in the probability plot correlation test for normality. A normal probability plot first used by Hazen is plot of ordered observations versus the inverse of the cumulative distribution function of the normal distribution. And it shows also Blum's plotting position is commonly employed and is given by this formula. I have prepared simple fictitious data, and once in our program, if you use AD.test, then you can see that this data doesn't satisfy normality because it is under 5%. So we can reject null hypothesis. Right. Once you test normality test by Lambda-Starling method, then you can think of finding optimal lambda to transform your raw data. So it shows optimal lambda as minus 0.0843, and the correlation is 0.985. Once you change your raw data by Box Cox transformation, then you can see that it satisfies actually normality, because according to Anderson-Darling normality test, if p-value is greater than 5%, then we can say that it satisfies normality. If you want to know more about Anderson-Darling test, please see my another YouTube contents. The title is 034 Anderson-Darling test in XLNR. In this video, I would like to show you how to get optimal lambda from PPCP method. This one, PPCC method. Right. Let's initialize lambda as like 0. Then lambda x can be let's say 0.5 or 0.1. Then you can consider this format. So y lambda minus 1 and over lambda. You can apply this formula for other cells. And in order to get optimal lambda from PPCC method, you need to calculate ordered number. So let's say 1, 2, and select 2 cells and double click it. Then you can generate a sequence. Then this probability position can be calculated by using this formula. So ID minus 0.375 over n means total samples, so we can use count function. And plus 0.25. Right, then we can use cumulative inverse of cumulative function. So rm dot has dot amv and probability. Right, then we can calculate correlation between transformed x, comma, and inverse of cumulative value. So we want to maximize this correlation by finding optimal lambda. So we can use solver here, click data and solver. Then we want to select this one, correlation. We want to maximize it by changing value, this one. And if you click it, alright, as you can see, we were able to get optimal lambda as minus 0.0843, which is same as our output. Right. So again, if you apply this optimal lambda for Box Cox transformation, then you can get transformed X. And if you do Anderson-Darling normality test by using AD.test function, then you can have this p-value. So it means that we can accept null hypothesis. So we can say that it satisfies normality, right? So anyway, the main purpose of this video is to find optimal lambda by PPCC, which is actually probability plot correlation coefficients. I hope this video is useful to understand how to do Box Cox transformation by PPCC. Please click like and subscribe if it was useful for you. Thank you.